Time is of the essence when identifying and resolving issues in your software, and our friends at Raygun are here to help. Their brand new alerting feature is now available for crash reporting and real user monitoring, and they'll make sure you're quickly notified of the errors, crashes, and front-end performance issues that matter most to you and your business. You can set thresholds for your alert based on an increase in error count, a spike in load time, or new issues introduced in the latest deployment, along with custom filters that give you even greater control. You can assign multiple users to ensure the right team members are notified with alerts linked directly to the issue in Raygun that'll take you to the root cause faster. Never miss another mission-critical issue in your software again. Try Raygun Alerting today and create a world-class issue resolution workflow that gives you and your customers peace of mind. Visit raygun.com to learn more. Their simple usage-based plans start from as little as $4 a month with unlimited apps and users. That's raygun.com, raygun.com, to start your free 14-day trial. Hey friends, 8 years ago I set out to start a weekly show to learn Azure from the people who built it. Back then it was called Windows Azure, and I used Visual Studio 2013 to build a website with the Azure SDK. A lot has changed over the years, but one constant has been Jason Zander at the helm. We're going to explore the past, the present, and the future of Azure today on Azure Friday. Hey friends, I'm Scott Hanselman, and it's Azure Friday. I'm here with Jason Zander. How are you, sir?
Doing well, Scott. How are you?
I'm living the dream, always learning about Azure, doing all kinds of fun stuff, get to talk to cool people on Azure Friday. We're coming up on 8 years of Azure Friday, 700 plus episodes.
Wow.
Super fun stuff. This is your first time, I think, on Azure Friday.
I think so. So. It's been a while since you guys have done a session like this, so it's good to be here.
Yeah. And then we're also going to do double duty. I'm going to put this show on Hanselminutes, which is my own personal podcast. We're going to use the audio twice. And I was looking into this, and it turns out that you were actually on Hanselminutes many, many years ago. I'm looking here at episode 63, and this will be episode 800 and something. So you were on the show about 14 plus years ago, and I was looking at your LinkedIn here. You're coming up on 30 years at Microsoft.
I think I probably have one extra gray hair for every episode you have done since then.
Mine, I have no more hair. But I do have a lot of gray hair in the beard, so it's kind of a nice inverted thing that's going on here. And you and I worked together for a little while when we were doing ASP.NET back in the day, because you were on the CLR.
That's right. Yeah, no, that's right. Yeah, I was one of the original software developers on the Common Language Runtime. Did a bunch of work in the compilers and the metadata formats and a whole bunch of things like that, and then eventually ran the team before I moved on to other different products.
Yeah. A lot of people don't realize that there's a lot of VPs and people in power at Microsoft that were devs. You were a dev for 10 years.
Oh yeah, definitely. Yeah, at one point I had code and Control-Alt-Delete. It's probably gone by now. But nonetheless, yeah, I was a dev for a number of years. So
yeah. Now I think it's fair to call you a Microsoft lifer because you came in straight out of college, out of Minnesota State. And have you worked anywhere else but Microsoft?
IBM. I did spend a bit of time at IBM. I worked on a couple versions of the AS400 and a few things like that along the way, which was some good experience. And at the time when I joined Microsoft, this was 1992, the company had about 10,000 employees, and we were still shipping DOS. I think it was shipping DOS 4 and working on DOS 5, if I remember correctly.
Wow. What are some good things and some bad things about having only worked at a couple of places? I mean, I think that there's something to be said for huge amounts of organizational change. You've seen the cloud go from not a thing to a thing and been involved in that. But then, you look at other people's resumes and it's 9 months here and a year there and 2 years there. What are the pros and cons?
Well, I think, and I pretty much have spent my adult life at Microsoft and raised 3 kids with my wife. I'm an empty nester now, so that just kind of shows how time flies. But look, I think from a Microsoft perspective, my original plan had been to come to Microsoft, maybe do 4.5 years, then go on and figure out what it looked like. And didn't really stick to that plan. But the big thing that was cool about Microsoft the whole way through is just the variety of things that we're always doing and new categories getting created and kind of disrupting ourselves even when it's time to go do that. And so there's always been something new to go learn, something exciting to go do, and things like that. And so that's why I've pretty much been here, but worked on a lot of products and a lot of different technology along the way.
That's an interesting point that we're now like 130, 150,000 people. Microsoft is not one company of 150,000 people. It's just like, 100 or even 1,000 little mini companies. And people have said like, when are you going to leave? It's like, well, I'll just go and work on Xbox, or I'll go and work on M365. I'll go work on Teams. Like these are all like little silos and stuff.
Yeah. And let's put it this way: they're all new product categories, technologies, new things that you can learn. I'm just being pedantic on silos because silos implies that
silo wasn't a good word. Sorry about that.
Yeah, which and that's frankly one of the nice things about Microsoft. We used to be silos. We used to have in fact, there was times where it was actually hard to move to some of those divisions because you weren't actually somebody who started here, so why would we want you here? I mean, there was some very interesting cultural stuff historically, and that stuff is gone. Which is fantastic. I was really excited to see some of the culture changes along the way. But nonetheless, you're met a point of there's always some cool tech. There's always something new to learn. That remains constant.
Yeah, that's a good point. Yeah, I think in the context of silos back in the day, they kind of shipped the org chart, and now there's so much collaboration within. Like I work in DevDiv, but I work on Azure Dev Tools, which is part of Azure, which is so. It's like in the old days that might have been in a vertical, but now the lines are so blurred. It's really just making great developer tools that happen to be in the cloud.
Oh yeah, no, absolutely. And of course, yourself, Scott Guthrie, a bunch of us, we're also DevDiv, folks for a very, very long time. The one nice thing about DevDiv that was actually true the whole way through is that we always serve the rest of the company. It was not only the developer tools, Visual Studio, .NET, and then eventually Java and VS Code and things like that. But then also the idea of looking at the platforms and figuring out how to go service those. And so in some ways, I feel like the rest of the company has taken on that same kind of model where there's a lot more collaboration than there used to be in the past. But the nice thing about DevDiv was you also got that viewpoint of pretty much the whole company. Which you didn't always get if you were in one of the kind of more vertical products.
That's a really good point. Actually, my buddy Mike Harsh over in Windows, who I've been working a lot with we work on Surface together and WSL, the Windows subsystem for Linux. He made this comment in a meeting recently where he's like, there's like 8 billion people on the planet, and they're all touched by technology, but there's maybe 60 million-ish, that's just a number, developers. Mm-hmm. 60 million developers are kind of like wagging the dog to help the lives and improve the lives of 8 billion people, 8,000 million people. So to be a developer is a really empowering and place of honor. We need to be careful about that.
Well, and then also our support for different types of developers has grown tremendously as well. Because of course, you go back 30, even 40 years, you had a lot of systems programming, much lower level, kind of stuff. And then we came along with .NET and dynamic languages, and now you got low code, no code environments and things like that. And, this was kind of like the natural outcome of VBA originally in the Office suites. And there was a lot of, kind of, I guess, citizen developers today, but essentially accountants and, people that worked in insurance companies and folks that weren't actually technically trained as a computer scientist. But that was one of the magic things about Microsoft, having come from a different kind of environment. That was pretty actually cool. And it's actually kind of cool to see some of that coming back and becoming even mainstream now.
Yeah, I actually started some of my early work when I was an intern going through university, coding in Access, which was like making full applications in Access. And then graduated to doing that full applications in VB and VB2 and 3, and then writing the C code to make the controls that other people would work. So I went down level and other people went up level. And now, you can be a developer on Power Apps, or you could be a device driver writer, and you're still both a developer.
That's right. Yeah. Look, I wrote a couple of X controls that, shoved in through the automation model of Office, because it was kind of like eventually, the automation piece you exposed to customers was never quite sophisticated enough. And, I wrote some DLLs that plugged in and pretended like they were part of VBA. And that was before Ole, by the way, right? So it wasn't quite as simple back then, but yeah.
Yeah. Now, this is not your grandparents' Microsoft. Certainly, there were different leaders over the last 30 years. There were different philosophies. How much of the change, the openness, the positivity, the inclusion that Microsoft has had kind of comes from the top versus kind of comes from the bottom? Because you've seen that entire experience change.
Yeah, I think you get a little bit of both, to be honest. I mean, like, so think of it this way. I think there has definitely been a push, and I give Satya a huge amount of credit. He talks very much about the growth mindset and being a learn-it-all, not a know-it-all, and that's something to try to practice. Even some of the ways in which we've been running the businesses at Microsoft are designed to get more cross-company synergy. I hate to use a $20 business buzzword, but essentially people working together. Like, wow, what a concept. Like, we should be doing that. So the top down thing has helped. And from a bottom up perspective, I think the cultural thing is happening, especially with younger engineers, or I should say engineers that are graduating from university and coming into the workforce, have never known a world that didn't have open source and that didn't have some kind of collaborative environment, and not just the IT, team project that you had to do to force you to figure out how to work on a team, but actually in a community. And so like you get both of those. And I think that can be a really nice force for everyone in between to say, wow, like we should continue to update. And I will just tell you that it's really awesome. Like there are folks that work on Office 365, very good systems programmers, engineers, the folks that do like Exchange Online and, all the underlying substrate work and stuff. That's really complicated, distributed systems work. And as we've collaborated more on, hey, how could that natively take advantage of Azure? We've actually got developers from that team actually working in our code base. And can you imagine someone from Office checking in code to Windows 25 years ago? I mean, like, that may not have been too common. But these are good examples of kind of how you can evolve.
So back in 2005-ish, I know that Ray Ozzie was the CTO at Microsoft, and he had been talking about, internet services requiring kind of a different way of thinking about services. Was there a cloud before the cloud? Because, I'm old, you're old. I'm going to go ahead and say that. When I was working on like 800.com, which was a big, Amazon, pre-Amazon thing, when the boss says scale the web farm, we go to PC Micro Center, we buy the racks, we rack them over the weekend. He comes back on a Monday, the thing is scaled out. We had to run our own hosting. When did hosting become the cloud? When did hosting become other people's servers in the cloud?
I think you can probably even look back, and I think if Kevin Scott were here, he'd probably say, hey, what about Loud Cloud? What about, there was some like precursors back then that were showing the way on some of this. And then if you look at it from the internals perspective, Azure has a particular brand date that's on Wikipedia. But of course, Xbox Live has been around for 2 decades. And if you look at the work that was done with BPOS-D, and some of the original hosted Office before it became Office 365 and became much more commonplace, those were essentially cloud technologies. And the way in which Live Messenger and a bunch of other products that, again, 20 years back, they were actually operated pretty much very similar to a cloud. The big thing they weren't doing was infrastructure as a service. And Bing, another good example. So it's not that we haven't had these distributed systems that, some of this technology that we would eventually even harvest and just make available for customers. Microsoft has been doing this for 20 years. So then it really just comes down to, well, when did you decide to turn it into something to make available for customers and then productize it, so that was possible?
I see. So Loud Cloud, 1999. So people like the term cloud, the thoughts there about an elastic infrastructure as a service was being thought about a very long time ago, like you said, 20 plus years. And then is it fair to say that before it was branded, before it became Windows Azure and then Microsoft Azure, there were several clouds? Like you said, Xbox had their own cloud and Office had their own cloud.
No, that's right. I would say from a Microsoft perspective, and ironically, you go back to the org conversation. The way things were designed is you would basically go in and you build out your technology based on your business need. And so basically the Xbox Live cloud was built in a particular way. BPOS-D was built by a different team. Bing was built by yet another team, et cetera. And so you did have a lot of kind of fragmentation Not a lot of sharing between them, except for the data centers and some of the networking. Those things, were actually shared. It's like, for example, you didn't have a case where each one of those properties would go off and say, "Hey, I think I'm going to go lease some property someplace and go set up in a colo." That was actually shared infrastructure for a very long time. But what went in it, not so much. 2 decades ago. But of course, and part of that is we have actually made significant progress. This is when I get back into we've got devs in Office checking into Azure. That's because, basically a huge part of O365, Xbox, et cetera, are Azure applications now. And, we had to go build it first. And it was recursive, to be honest, because parts of the core of Azure came from some of those original work that was done even over the 10 years before Azure. So that, because there's some great systems work down there, we were able to harvest some of that as well.
And then just to make sure that we expand an acronym, you said BPOSD, the Business Productivity Online, it was a group of hosting services that was Exchange and SharePoint, what used to be called Office Communications, and then Live Meeting. So a cloud of its own before the cloud. And,
again, for anybody that when I mentioned DOS, thought that meant denial of service, some of these terms, they had different meaning back then. And to your point, that particular product was Microsoft's thinking about, hey, what we really do as a company is build software and give it to customers or partners, and they license it and they run it. That was our business model, and of course we still have that business model for a lot of different products. The idea of taking that and then us doing the hosting of the data center on behalf of the customer, that was really kind of weird at the time. Now, of course, today, fast forward, 20 years later, and it's SaaS. Like, why wouldn't you go do SaaS? It's like, well, because SaaS didn't exist back then. So, that was actually, again, you think about the history of the cloud and Microsoft. It's not just the 10 years of Azure. We've actually got a rich history that's probably about 20 years back overall from an experience perspective.
Mm-hmm. If you have a mission-critical application, you don't deploy it as a monolith anymore. There's a reason Kubernetes is so popular. So why are you still using a monolithic database? Yugabyte DB is a distributed SQL database that you want for your global applications. It's 100% open source and designed to be resilient and horizontally scalable out of the box. It's PostgreSQL compatible, so you can start using it right away without learning a whole new query language. And you can distribute it wherever your application takes you, across availability zones, regions, and even cloud vendors. Go to yugabyte.com, that's yugabyte.com, and try the free beta of Yugabyte Cloud. It's a fully hosted and managed Yugabyte DB as a service, giving you a distributed SQL database for global applications with no operational overhead. It's effortless distributed SQL for global apps. When I think back to myself racking servers, I think about actually more organizing the wires. I remember flying F5 networks consultants in to help us with things like round robin DNS, which was a big deal in the early 90s. We hadn't thought about how to do stuff like that.
Totally.
But from a technology perspective, there's one thing that stands out to me as something that was required before the cloud happened, and it was called software-defined networking. How fundamental of that? Because when you're announcing Azure, in Project Red Dog in 2010 or so, was software-defined networking a thing yet, or were there still people in a back room somewhere with cables?
Like back then, and of course, this is quite a while ago, we did have software-defined networking. That was actually a core part of the original Azure prototypes. When you mentioned Red Dog, that was the prototype name for the small team that started to prototype Azure before we went live in 2010. So we absolutely had, software-defined networking. I would say the scope and the scale, of course, has gone significantly higher. And again, some of the original, kind of web-facing, hyperscale properties, Bing and et cetera. Bing had, software-defined networking. We actually harvested a lot of that code into Azure. Actually, a big part of Bing, the core of Bing that actually did scheduling and nodes and networking actually came and became Azure networking, and a big chunk of Azure core, Azure Compute. So we did have that. But there was other parts of the system, again, we're going way back, that were actually run by more classic, almost IT style things. So scripts and queues and, programming interfaces and things like that was not really software-defined networking. It was basically queue dispatch type stuff, right? Which is kind of what you'd expect. But now fast forward. Not only do we have had software-defined networking for the last 10 years, but along the way, we invented Sonic and released that and other ways of, again, going back open source. Sonic is a great example, right? How do we go back and actually take some of that technology and actually make it available to others and encourage an ecosystem to get created?
Well, and not only did you harvest some things from Bing, you also harvested Satya himself from Bing during the early Azure days. So he had that experience in the emerging cloud, and then eventually, came in to transform that group.
Yeah, absolutely. And the nice thing about that, since Satya did run Bing, and of course Satya had also been, back in, doing business apps and things like that, kind of more in the classic server and back end software side of the house. So he had a really good background for that, which was super helpful. So that when he came over originally to Azure before becoming CEO, he had the experience of both, like server related products that we license and sell and users run, and the cloud in between those. And so actually give Satya credit for kicking off some of the convergence work that, I've spent a significant amount of time getting the company kind of on that same page. And that was, even things like, hey, let's optimize for global maxima, not local optima. That was okay. Wow, that's not exactly what we've been doing, but it's actually smart. And that those kind of principles were things that Satya brought in and said, we need to go do this. And then frankly, it was his idea for us to take some of that core part of Bing and say, there's some really good high scale distributed systems in here. And we've got Azure and Azure Fabric. We should figure out ways of pulling those together. That was one of the early convergence projects, was how do we take the high scale stuff that works for like a property like Bing, but then also make it work with something like Azure Fabric, which, in a lot of ways was designed more for what you might think of like your enterprise workloads. Like I've got virtual machines and I'm running SAP, and which is hugely different than, I want to shred laugh out loud cats and petabytes of data every single day. Those are two completely design patterns. And so us bringing those types of code together and creating one cloud out of it actually turned out to be a real magic combination.
So I was watching a video of you from about 15 years ago where you were breaking down the internals of the CLR, and you were talking about like low level stuff. Like I feel sometimes like I'm talking to you and it's like, hey, I'm the guy driving the race car. But hang on, let's just stop. Let's put the race car up on blocks and let's go underneath and let's talk about disassembling the engine.
Yeah.
How do you find the ability how is it possible to lead something at a high level and think about business requirements and OKRs and global scale, but then you're also able to apparently drop down to the packet sniffer level and talk about that? How do you stay both technical and high level, business focused and deeply technical at the same time?
We were debugging a bug check 2 weeks ago that had an impact, which is quite interesting. So kernel level, mode, crash someplace. I guess, just the way my brain is wired, I understand stuff better when I know how it works. And I can do hopefully a better job helping guide it and spirit it forward. And, the reason why I was a developer for so long is I've always kind of had an intuitive sense of how systems and trade-offs and stuff kind of work, which has been super helpful for me. I think so I do actually know how a bunch of this stuff works. Now, at the same time, when your team becomes bigger and becomes, big enough, especially, you're doing your team a disservice by trying to be the armchair architect, the armchair developer. And I'm probably guilty of doing that way too much. Totally get it. My friend Scott's probably an armchair PM. We're kind of wired in a similar kind of way, just different disciplines. So I think it is helpful, but you have to actually concentrate on what are the higher level goals. What are you trying to accomplish? But I have found it quite useful that when I'm talking with teams and we're going through stuff and it's going to take, 4 months to do this. It's like, oh, really? I mean, let me ask some questions. And then maybe sometimes the numbers change after we finish having a conversation. That can be quite helpful.
Yeah. My boss, Scott Hunter, has called that having a good BS detector.
Yep.
So he's not saying in any way that he's going to jump in there and necessarily debug that dump with people. He's got other things to focus on, but he can definitely go, really? When it comes to estimates or architectural guidance.
Yeah. I've known more than a few folks like myself, and there's some funny stories in the past where people said something would take too long, and they went off and coded it over the weekend and came back in and said, about that thing, here it is. I mean, so again, you don't want to disempower your team. You don't want to go do that, but sometimes it can be good just to, well, for one thing, establish your understanding, because this cuts both ways. Like that was an example that way. Let me give you an example of the other direction, which is if you think you understand how it works, but you really don't, you can also have the other fallacy, which is you're trying to force people to do things too quickly. It's more complicated than you think. And just because you see the picture in your head doesn't mean you have an accurate, kind of idea of what it really takes. And so that can actually be a downside of, being super technical, is that, sometimes if you don't do the homework, you got to be careful about trying to tell people they could do it faster, they could do it more efficiently. It's like, you got to trust the team. They're professionals for a reason.
Yeah, you definitely have to trust the team. So kind of fast forwarding from the past to the present, how many regions are we now? 50, 60 regions?
Oh, it's like 60 announced, something like that. I can't keep count. I see it like every week, but it keeps going up, and all over the world, we keep seeing more and more.
More and more regions. There's like over 100 services plus. There's also the hybrid cloud. So you got both Azure Stack and Azure Arc, which is unbelievable. Like I actually have a stack of Raspberry Pis in a Kubernetes cluster, and I can add that to Azure and control it from a plane in the Azure portal as if it's a piece of Azure, and then running the services locally.
Yeah, that's really cool. It is really cool. That was Mark Rusinovich did a similar kind of demo when we first came out with that, and then he actually had a Dapper on top of it, so you could actually test the, getting all the components distributed in the right way. So
you couldn't have conceived of those things, right? What are parts of Azure that have surprised you? We're just like, oh wow, okay, like it's not just websites in the cloud. You're like, that's a thing I didn't think we were going to be able to do.
Well, I think that, it's, if you look at some of the most interesting workloads and things that we've had to work on, I'd say, kind of like doing HPC, massive HPC clusters is super interesting. AI supercomputer, which of course Kevin Scott has blogged about, when you're doing massive scale, work and et cetera. I mean, just read the blogs on AISC. Those things are like unbelievable. And that was not, like I remember going back again when Azure was a prototype. It was a very, very long time ago. We knew the name of every cluster. It was in a spreadsheet because you're prototyping, right? You haven't released it to your customers yet. You actually knew the name of the clusters. I pointed that out to somebody yesterday who's been here forever. Like, oh yeah, ProdApp 03A. I hated that thing. It's like, and of course, at this point, that's just ridiculous. I mean, you've got, such volume, such scale, that's just silly. And I think any new hire to the team would go, how is that even possible? Really? I mean, like, again, go back far enough before you released it. You're still prototyping. That's what the world starts off like.
Somebody asked me, how do you know it's a cloud? And I says, if you can visit your website and touch the machine it's on, it's not a cloud. But if you can't touch it because the disk is here and the compute is there and the memory is there, then it's probably a cloud because it's really well distributed and elastic.
Yep. Yeah, exactly.
So looking forward, I know that you're really excited about quantum. Is that the thing that, like, because I mean, you've been here 30 years. Like, you don't have to come to work in the morning. You could just like hang out. You said you're an empty nester. There must be something that gets you up and excited.
Yeah, no, there's a bunch of stuff that I think is still super interesting. That's great. And the cool thing is, I know Microsoft has done amazing stuff since it was founded 45 years ago. It's going to do amazing stuff in the future. When we're gone, any of us is gone too, it's going to be pretty awesome. So I'm not really worried about Microsoft continuing to innovate. But picking a particular technology that I think is interesting to look at, I do think quantum computing is incredible. And one of the ways that I could kind of describe this is, if you look, like here's a way to think about it. The human brain is using 20 watts of power to operate. It's got 2 petabytes of onboard storage. It's got AI, basically inferencing machines built in from your eyeball to your brain to your muscles. Wow. Okay. So ask yourself, what would it take for us to do the equivalent inside of a data center? And it's probably megawatts, right? And it's not petabytes. It's, it's at least petabytes, but lots and lots of petabytes, and then, lots and lots of cores and lots of electricity. And so if you think about this, there's kind of this thing, which is, okay, we've invented, chips and science and everything else, and they do amazing things, much better than humans can, and they scale unbelievably. And then there's nature, and nature does some pretty freaking amazing things too. And so if I look at something like, DNA storage, which we prototyped, which is really kind of cool, massive, can last 2,000 years, hold a bunch of data. The reason why I mention this around quantum is quantum leverages quantum mechanics. And so if you think about that, that's leveraging pure nature and the mechanics of that, and not just the sort of things that we would do in a typical chip, with basically ones and zeros and basically making sure we can control electrons and make them smaller and smaller. But, actually, with quantum mechanics, that's kind of cool. I mean, that's really kind of amazing.
There's a really fun quote from a person named Daisy on Twitter who said, have you ever just code something and you're like, oh, this is a hack, but it works. And then you say you remember that a CPU is just a rock that we tricked into thinking.
Yes.
And then at the bottom, they said, well, not to oversimplify, first you have to flatten the rock and then put lightning inside it. And then you have a thing that thinks. That's amazing that this entire stack consistently continues to work.
Yeah, no, it certainly is. It certainly is. And, it's just a testament to lots and lots of decades worth of innovation. And yet, if you think about, what does the world look like going forward, I think leveraging physics in a more raw form to use physics as opposed to, again, just silicon and substrates and controlling electrons and buses and blah, blah, blah. Like that is actually an amazing thing. Being able to explore a solution set all at once using wave functions and algorithms that, get closer to waves. I mean, like, holy cow. I mean, that's just significantly different. And of course, we'll keep improving the classic work and everything else as well. There's a significant amount of work being done there also.
Yeah, I remember starting with my first computer. Well, before there was Apple, Apple IIe and all that kind of like, TRS-80s. But like when I bought my first PC, I think it was a 25 megahertz.
Yeah.
And now we've kind of been stuck at about 4 or 5 gigahertz for a while. And we always hear about nanometers and we're getting down into the quantum level. What you're saying is, all right, we're going to hit quantum effects. Let's start using those quantum effects for good. Let's work with physics and work with nature.
Yeah. I mean, the general theme there is right, which is, figure out where does nature do something better or more unique. And then go pull that in. I think the big difference on some of these is that your classic CMOS chips, at some point things are governed by the underlying physics. That part's fine. But the approach for quantum computing is fundamentally different, right? The approach there of a qubit is basically the notion that I can actually explore the entire solution space with the right algorithms. And again, it's the old, I'm beaming light at the split thing. And why does it kind of gather in a couple of places? There's these things called waves. And like, if you think of that particular screen that, lets the photons through in particular ways as the algorithm, that's how you find the answer. I'm spraying every possibility at it and the algorithm picks up the one that matters.
Right.
Right. That's kind of an interesting way to kind of twist the way it works. And of course, that means that it only works, we think, for algorithms that lend themselves to that kind of pattern. So it's not going to be used for everything that's out there, but there are certain things like material science and chemistry and, everybody's, talking about crypto, but, those are the sorts of things that I think will light up.
Right. Let nature propose all possible solutions and then pick the Loki variant that works for us out of the multiverse.
Yes.
Very cool. Well, thank you so much, Jason Zander, for hanging out with us today on both Azure Friday and on Hanselminutes. I appreciate your time.
Well, thank you, Scott. I appreciate it. It's been a long time, but it's been really great to be here. Thank you.
All right. We're having all kinds of fun here on Azure Friday. Hope you stick around. We've got a catalog of over 700 episodes. And if you're listening to this on Hanselminutes, there's over 800 episodes for you to check out, including one with Jason Zander many, many years ago. Thank you, and we'll see you again next week.